Hello, welcome. My name is Alex Wells, and as a grad student, I was required to look into the disciplinary literacies within a science classroom and how it compares to content area literacy and how that it has its own separate framework. So let's see here. Yeah, so ideally I'll be teaching high school science, hopefully like biology, environmental science, or earth science, but I'm also open to teaching physics. And after presenting on these different strategies, I will go over in greater detail some strategies for using disciplinary literacy and content area literacy in the classrooms. So first of all, there is a debate going on within researchers between these two subjects, content area literacy and disciplinary literacy. So to start off with, content area literacy is more of an outside-in approach, where the main belief is that once you master a set of strategies, they can be applied to any content area. These strategies are largely taught in elementary schools, whereas Brozo et al. Puts it, students are learning to read. Teachers set goals and give tools such as monitoring for comprehension, pre-reading, setting goals, activating prior knowledge, asking questions, making and evaluating predictions, rereading, and summarizing, as Lee and Spratley put it. So it's the content area literacy is just definitely more of a general literacy that you would learn in elementary school, and this then brings us to disciplinary literacy, which is more of a reading to learn look at things. It's an inside out. Every content area has its own specific set of strategies that is specific to that discipline. So you have disciplinary literacies for math, science, history, dance, art, you name it. And readers must base what strategy they use on what purpose they have for reading the literature themselves. So with these two in mind, there's a lot of people that a lot of the research we were reading has one versus the other, but really though I think that we can bridge that gap. There isn't really a necessary reason to have one or the other, because we need both of them. First of all, you're undoubtedly going to run into students in your high schools that didn't learn content area literacy as well as they perhaps should have. Additionally, though, Brozo et al. Shows that without good disciplinary literacy, there isn't a real amount of learning happening within a high school classroom. So yeah, I guess there's research that shows that they can be taught alongside each other and super well. And Brozo et al. Shows that also that talking to other teachers is keys and collaboration is crucial, such as getting literacy ideas from English teachers or how to teach graphical literacies from math teachers. Which actually brings me to my next point. The science itself is a hybrid content area, which makes it extremely harder to teach than English or history, which actually might get some raised eyebrows from English and history teachers, but as it goes, science is not only just learning about life and everything else that is tied into that, but there's, like I just mentioned, it's also, you have to have content area literacy in math and in visual sense as well, because you're looking at graphs and looking at numbers and tables. Additionally, it's an inquiry-based approach field. So you're not just reading for causation and bias like in history, but you're reading for discovery. You're doing labs and you're experimenting, and that in and of itself means that it's definitely a separate subject area than any other topics, and it can be more difficult. And lastly, one of the more interesting ones to me is that science has multiple registers, and Lee and Spratley put it this way, that each field within science has its own syntax. So if you go to a botany class, you'll have to run into different terms than if you went into a biology class or a chemistry class or even a psychology class. So this actually makes it hard for students who don't have a good grasp of any content area literacy skills to grasp what the teacher is teaching, and it makes it hard for teachers as well, because you're going to have a field full of students who are going to have different levels of literacies as well. So And that brings us to the next point here, where we look at literacy and inquiry. So this is another semi-debate within this area of study. Some researchers think that a focus on inquiry means less literacy by nature. But on the other hand, other researchers feel that too much literacy doesn't really lend itself to teaching a good science class. That's what Cervetti and Pearson said. So that if we focus too much on literacy, then the actual science part of the process is lost. Additionally, sometimes if we just entirely lose the inquiry, sometimes you'll run into science classes where they just replace labs with reading, and that's like the entire pendulum swing too far. So I guess the point of these quotes is to show that literacy can grow as a byproduct of good inquiry-based instruction, but teaching these concepts don't inherently conflict with each other. No scientist is going to walk into a science lab, turn on a Bunsen burner, and start doing science without first reading. Experts are experts in their field because of the reading that they've done and the background knowledge, the background disciplinary knowledge, that they have on the topics. Disciplinary literacy definitely needs to be learned by our future students for this reason. And even if they don't go into the science field, it's important to be able to read articles well and look for bias and understand authors and be able to understand, especially in the era of fake news that we're in right now. And one quote that I just want to throw in here as end idea for this slide is that texts are artifacts of past investigations and are used for inductive reasoning about scientific phenomenon. So they definitely go hand in hand here, just as content and disciplinary literacy also can go hand in hand. Right, so an overarching theme that I ran into through a lot of the different articles I was reading, as you can see at the bottom here in the citations, is that it's important to stress learning content area literacy and disciplinary literacy, and I guess overall get them thinking like scientists. And to me, I'm going to be a science teacher, but scientists, the association with science is heavy journal articles and lots of reading. And I guess the point here is that while there is definitely reading in the science field, it's not all just that. If you go to a scientist or a researcher or a developer, they'll be using field guides or lab reports or hand guides and graphic visualizations. And Cervetti and Pearson told us about that. But while they're reading, they also are practicing good skills such as questioning, checking for biases, looking at the author credibility, the subject size of the study, what methods and statistics were used. And lastly, to compile this data, there's a few strategies that is helpful for students as well that authentic scientists do take care of. And while they're reading, they'll annotate notes and draw on the margins and circle words and whatnot. They will make drawings, and I can attest to that when I was in my geology class last semester even, there was a large amount of drawing of landscapes that happened. And that actually was really interesting because it tied in left brain and right brain thinking and really helps cement an idea into your head. So drawing as a vocabulary instrument is very important to me that I will be using in my future classrooms. So moving on to teaching some of these strategies, I did just cover a few of them, but so an overall theme throughout these articles is that first and foremost, first-hand investigation must be the focus. Inquiry-based is the new way of saying hands-on, and I guess that the point with this is that we need to be able to let the students discover things on their own. We've read over and over again that we can just tell them things, but if they remember is if they're learning on their own. So they need to be able to discover things, which is why labs are so important to the science field. Additionally, visualizations are huge. We need to not just show them, but we also need to have them make visualizations as well. Again, because drawing things on their own helps cement things and cement their own learning. Let's see, and also drawing to learn is more appealing than traditional science methods, as Ainsworth said. Additionally, we could bring in some moral and ethical dilemmas to get kids' brains and inquisitiveness involved here. Because the science field is just riddled with lots of interesting dilemmas that you can take sides on and bring up and ask kids what their ideas are and their opinions are. And by doing that, that makes them interested. And I guess that's part of the point here is to spark that curiosity in them. And lastly, on this slide here, we got classroom discussions and wait time. And discussions is a very authentic strategy and context for scientific instruction because every scientist is going to contact their colleagues and discuss findings and ideas. Science as a field isn't a one-man job. It's you're working in a huge field of people that also are working on perhaps similar things as you. So overall here, some of the takeaways that after reading all these graduate articles, first of all, that I just highlighted last one, that literacy activities should be held as supporting roles with inquiry as the main focus. So as much as possible, I'm going to be making students do labs and having them discover things on their own and definitely walk them through the inquiry process. And then secondly, there's no question that just disciplinary literacy and content-aware literacy are both important to education in the science realm. But to definitely do the best job possible, I'm going to strive to collaborate with other teachers for best practices when given the opportunity, as far as having kids learn how to be math literate and visually literate so that they'll be able to best understand scientific articles and be able to receive the most that they can. So that actually wraps up my presentation here, and I just want to thank you for your time. And yeah, if you have any questions, definitely just give me an email here. All right, thank you.